Hey, hello, Math 10. It's good to see you again. We're starting a new unit in Math 10, and I'm excited to be talking about Chapter 3, which is called Relations, but is really mostly about graphing, which can be a nice break from some of the stuff we've been doing. A lot of the stuff we've been doing has been very abstract, I guess, not very visual. So graphing can be a little bit more on the visual side. Not always. There's going to be some sort of algebra stuff we have to do and things like that, but I think it might be a nice change in the course. We're going to be doing quite a bit of graphing. This isn't the only chapter that has graphing in it, and I think it's the second big idea that's going to come out of Math 10. Factoring was a big one. We worked really hard on that. And then a lot of stuff about graphing is going to be really integral to all the next layers of math 11, math 12, if you want to do that, calculus, and so on. So this is going to be a really important chapter as well. This one, chapter 4, and chapter 5, all are kind of connected together with a lot of these ideas about graphing. I just wanted to talk about the word relations. First of all, here it is, relations. The whole, I don't even know how this isn't really working. There we go. This word relations is a big deal. I mean, it's actually kind of not a big deal, but I want to make it clear what we're talking about because we're going to be drawing all these graphs, and it's going to get away from real-world examples real fast. And I wanted to just ground us in real-world examples of what relations mean before we get into all the math. So relations are basically like two sets of numbers can often be related, and we can use and understand those relationships in order to build mathematical models to understand what's happening or predict the future. That's like a big idea in mathematics. Did you hear the word I said just a minute ago? Predict the future. That is like magic, right? That's literally like, wizard style magic that we're talking about, predicting the future, crystal ball, kind of stuff. And that is huge. That is what graphing and relations are often all about. So, for example, a relationship between two numbers. I thought of a couple ideas, and a good example would be your age compared to your height. So young children are quite small. Not all of them are the same size, of course, but the younger you are, the smaller you are. And as you go up in age, you will increase in height as well, and weight and other things. So I'll tell you a little thing about my past. When my children were born, they were born premature, which means that like they weren't at the full like 40 weeks or whatever. They arrived early. They're twins, so that often happens with twins. But they were actually quite early, and so we were keenly aware of the relationship between their age by like week, basically, and their growth. We really had to chart that carefully because that could predict whether or not they're growing and whether their bodies are changing in the right way. It was really important. They started off at only 3 pounds, and they were like this big. They're tiny little guys. So that relationship between their age and their weight and their length, I guess we called it because they don't stand. So when babies are born, you call it length. But as you get older, of course, it's height. That was a big deal. And the doctors had all these mathematical models. They had these charts with curves and graphs and things that would show us what the correct growth would be to expect. And our kids happened to do really well on that chart. As they grew, they kind of progressed on this mathematical model that doctors had invented over years and years of practice. And so we could see that things were going well. So that mattered a lot to us. So that was a graph that like deeply affected me in my lifetime. It was this model of like the relationship between your age and your weight. And as you get older, you can just sort of know, like, it's no big deal. You get taller as you get older, and you can sort of understand that. Eventually you stop growing at, whatever age that is, 18, 17, maybe a little later for other people. So those are all sort of relationship between numbers, right? There's so many relationships between numbers. If you have a job, you are keenly aware of another relationship. The number of hours you worked compared to your paycheck, right? So the more hours, that's a real easy one. That's a pretty straightforward. That's called a linear relationship. Really easy to predict. If you work an extra shift, you work 5 more hours, it's not hard to predict how much your paycheck will increase. But that's still an important thing to do. And you can use that relationship between the number of hours you worked to the paycheck you get to predict into the future of how much money you'll have, say after 5 months of working at a job or a year of working at a job. You can build a simple mathematical model to know how much money you're going to have made, and therefore be able to think about what college you can go to, or university, or can I buy this cool new computer or a PlayStation 5 or whatever it is that your goals are. So that's another example of a relationship between two numbers: your hours you worked and the actual money you get in your paycheck. You could, if you don't have a job, it's a little bit more complex of a model, but the amount of time you study in a course compared to the mark you get on the course. Unfortunately, that's not a linear relationship. You can't guarantee just because you spend a number of hours working on, say, math or English, you're going to automatically get this grade that comes out of it. So it's a more complex model. But there is definitely a relationship there, right? There's a relationship between how much effort you put into a course. It might not be the number of hours. It's hard to quantify effort, but the amount of effort you put into a course and the grade you get out. Sometimes it doesn't feel that way, though. I know I've sometimes put in a huge amount of effort into a course and not gotten the mark I wanted. So I know that model is a complex one and probably has a whole lot of things going on. Last but not least, I wanted to mention actually two more models, two more relationships. We were talking about trigonometry before winter break, and that's a relationship, right, between the angle and the lengths of the sides that a right triangle has. It's entirely a relationship. It is a relationship between these numbers. And that's a whole branch of mathematics based solely around the relationships of angles and side lengths in a triangle. And that's a perfect example. Last but not least, here's another relationship. Oh my gosh, this relationship has been ruling our lives for the last little while. I've never been more afraid of a graph in my whole life. The infection rates of COVID-19, right? This is a big graph that we see. And it's hard to know exactly what the relationship is here. We're taking a look. This is a particular chart that's sort of a prediction of infections. This is daily count of number of infections. And here's like the date. What they're really relating is the data of how many infections there are and estimating sort of what the next number of infections will be in the future. And so there's a relationship between future infections and current number of infections. And they're using sort of these complex, maybe not complex ways of estimating these things. But they produce mathematical models that governments have been using and has truly affected our lives. You can see in this one, they have these different curves over here. Do you see? Oh, sorry, my face is probably in the way. I'll move it up a bit. We have these different curves. The red curve at the top, the really big one. I'll gesture over here. It's that big curve up here. It's what they estimate the number of infections will be if we ease restrictions and don't do anything else. And then here's like rapid rollout of vaccines is like definitely a lower one. The green one, the lowest one, that's what will happen with mask usage. So if we, these are all estimates of what will happen. And these estimates are based on the relationships that people have studied through all sorts of different means and sort of predicting the future. So to go back to our chapter 3 about relations, we're taking a look at relationships between numbers and using, eventually we want to turn these into mathematical models to use to predict the future. And we're going to be kind of leaving that big picture idea, unfortunately, and kind of looking at some really specific examples that have no context. Like we're not going to talk about necessarily money or infection rates and that kind of stuff. We're going to just look at pure numbers. But don't forget that. Keep that in the back of your mind that this is what this unit is really all about. And this is laying the foundations for doing that kind of science, doing that kind of research, and understanding, the future, making these interesting predictions. So this is our sort of intro video. We'll come back in the second video and we'll talk about some of the questions you'll be answering and how do you do this kind of stuff. Okay, so thanks so much. We'll see you in the next video.